think of that. So anyway, the next speaker has a huge history in chemical recycling. He was there since the beginning. He's a founder of Agilix, and he's got 8 or 9 patents. And he has been so involved and so knowledgeable, and he's got more scars than probably anyone. And now he's becoming more an expert in plastic, feedstock, feed prep. And I'm looking forward to hearing his new adventure or new episode here. Anyway, this is Kevin DeWhitt.
All right, I'm going to go off script. Gene, you don't have to come back. I love to have conversations. AV guys, can I walk down in front here? Yeah? Good deal. All right, I'll be right in center, guys. We're good. Great. Other thing I'm going to do is I'm going to show you guys lots of pictures. 9 slides. It's nothing. We'll get done way early, okay? But I'd love to take a few questions sort of interactively. So if you have a question, just say stop, ask the question. I'll repeat it so that the Zoom people can hear the question, and then I'll try to answer it. Sound good? So I was telling Gene at lunch, none of you guys were in here, but Gene and I said, I'm more than pleasantly surprised with the depth and the breadth of the expertise that we've heard about so far. Didn't expect that, quite frankly. Didn't think anybody's dumb or anything like that, don't get me wrong, but the level of content that I drew from in terms of my my sort of edification and my lifting up of my own knowledge was just amazing from this morning. So thank you all before lunch. We've got a lot of catching up to do afternoon groups. So my name is Kevin DeWhitt. I'm the founder of PDO Technologies. Before that, I founded Agilix, and before that, I worked for a company. Well, we'll just go through the history here in a second. Everybody asks me what PDO stands for. I made this up. I'm a chemist. I'm not a marketing person. What does PDO stand for? And when I started the company, I tried to get a generic acronym. And so PDO stands for plastic derived offtake, all right, which is actually sort of universally true. I had no idea that the oil companies would sort of come around and say, oh yeah, we get that. That's a great name. You know, I wish I could have taken credit for thinking about it with you guys in mind 10 years later. But So we're in the roaring 20s of pyrolysis, all right? Anybody knows the phrase, the roaring 20s? You old people, sort of, Ron at least is probably, yeah, I know the roaring 20s. I was there, right, Ron? Okay. No, this is the roaring 20s of pyrolysis. And so I thought, let's take a look at the roaring 20s of pyrolysis, the 2020s, not the 1920s. So all I had to do was look online and say, plastics pyrolysis, you know, this decade. And this young man came up. And I love it because social media was not a thing back in 2000 when I was starting. The internet was barely a thing. So he's got this device. I created my own gas station. That's probably not his, there's probably some journalist's hyperbole, but he's working on stuff. He probably had the brilliant idea of sort of hiding in plain sight because he was worried about having the oil companies sort of come chase him down and run over him or something like that, because he hid for a couple of weeks. Nobody knew where he was. Instagram went crazy. His GoFundMe site went crazy. And I'm like, wow, nice effort. And that works. He's working hard. It's a microwave technology, Brian. You probably know this. But I'd never heard of it. So Julian Brown, he is the new Roaring 20s pyrolysis guy. So a century ago, or last century anyway, this was me. This was us. That pile of plastic. So I was the camp photographer for Environmental Fuel Development Corporation, which means I took all the pictures. And because I was not an employee technically, I copyrighted and took all of the pictures myself. So I own them. No copyright problems here. So that pile of plastic on the upper left, we ground through a limb chipper, because that's the technology we had. Size reduced it, put it into that upper right device, which we affectionately called the flying saucer. And we made this bucket of stuff on the bottom left. Not nearly as pretty as Julian Brown's fuel, by the way. Didn't stop us. We poured it into a truck. that had 2 diesel tanks, one with diesel in it, and the other with our nice brownish liquid, which is full of microcarbon. So you can see the pictures there at the bottom, pouring it into the truck with the funnel. And then my friend there in picture number 2 at the bottom, Jay Aston, he and I took a drive around Kelso, Washington in this truck. We started on diesel fuel, drove about 3 miles around the perimeter of Kelso, hit the switch, and kept driving. And did one perimeter of about 15 miles around Kelso, then did another perimeter. And we knew we're running on our own plastic. We just took a pile of plastic, went through a machine, made some stuff, put it into a truck, and it worked. That was freaking unreal. You would not believe the excitement everybody had. So we had this great excitement. I was just a consultant for the company. I'm an analytical chemist and physicist by training, so I was trying to analyze and see what we were actually making versus what they thought we were making, which was diesel fuel. We're making diesel. Like, just not quite diesel. So did a bunch of stuff, undercapitalized. That's okay. I'm a big fan of grading myself. I'm a tough but fair grader of myself, I think. You'll have to agree. So I looked at the EFD effort, and we developed, I told my team, we're using this metric. The dollars per ton per day of processing is a metric I use in this space. So Brightmark's $250 million plant processes about 250 tons per day. So you're spending about $1 million for every ton per day of processing throughput, right? Make sense? Yeah? So in terms of the CapEx on a dollars per ton per day, I gave EFD a B-. It wasn't super cheap, but it wasn't over the top expensive, right? Their OpEx, better than average, I thought. Now, we had no baseline, mind you, back in the day, but pretty decent. Seemed to be a lot more guys, though, fixing stuff and doing stuff than I thought was sort of production-oriented, and that was supposed to be a production machine. So C+. Feedstock acquisition strategy was brilliant. A local trucking firm in Kelso had invested in this company, and they would run hog fuel from Kelso to Albany, Oregon. You guys don't know your geography, it's just south, down I-5. So their plan was, we're going to make contact with people, we're going to run hog fuel down, and we're going to backhaul their waste plastic back to Kelso. Already making the trip, why do it deadheaded, right? Why do it empty? But that was brilliant, because you're actually working your logistics. And if you're a trucking fleet, you know all these things, and you do these things. That was good. Feedstock prep, equally good. We used a limb chipper. We got a little bit better with granulation and other stuff, but it was pretty good. You could just sort of grind everything in, throw it in. The feedstock specification was incomplete. We were throwing everything in. I've got pictures of buckets of oil with this nice white cloud floating above them, and people would say, what's that white cloud? That's the result of PVC pyrolyzing into hydrochloric acid and sitting on top of your bucket as a cloud of hot hydrochloric acid vapor. Andrea's already shaking her head. We did wear respirators, so there is that. Technology efficacy, an F. They failed. This thing would work for 15 hours or so before everything was coked. And we all know, well, Brian doesn't know, he doesn't deal with coke much. We all know if it's a hot surface, you're going to coke it up, and that coke its carbon is going to inhibit heat transfer, and you're just going to get into this death spiral. And they did. The market conditions are very interesting. A good friend of mine, which probably a few of you people know, his name is Bob Render. He used to work for Maine Plastics, then Ravago, now he has his own company. He visited in 2001, and he asked this great question. I'm just a consulting scientist. I'm listening to the CEO talk to this guy. I don't know either one of them very well. I know the CEO's a bit of a hothead, and he was. And so he's showing Bob all these Gaylords full of plastic. And he says, yeah, we turn all this stuff into diesel fuel. And Bob says, goes over and scoops it up and says, why would I take 35 cent a pound plastic and run it through your machine and turn it into 21 cent a pound diesel? I said, that's a great question. How's that going to get answered? The answer was pretty simple, get out. He didn't want my CEO, the guy that paid me, Didn't want to hear that. Get out. Hit the road. It's a great question. Market conditions were not very favorable towards making diesel. All right? So, lesson learned. Now we get to Plastifuel. I start the company in 2004. It does become Agilix after a number of years in terms of name change. But there's our technology, gens 1, 2, 3, and 4, right? Sort of left to right, top to bottom. Batch system all the way, very small. You gang batches together in the fourth picture there, bottom right, and you have a 10-ton per day system. One of the key flaws in this system was you can see all of those pipes. Let's see, does this laser work? Yeah, there you go. All those pipes right there lead to a single, what we call the dropout tank, but that only has one port going to a condenser. Anybody want to take a guess what happens if it clogs? Just saying. You probably get the first of many, many pyrolytic fires, which I have done. Not proud of that. I've been as stupid as anybody in the space has ever been. You have not seen the fires that I have seen, that I've created, but that was one of them. We didn't think it through. We didn't have any pop-off valves, any safety. We just sort of plumbed it and went. So, good efforts. We took small amounts of capital and kept improving the system. And this was all angel money, right? If you don't know what that is, talk to Andrea later or myself. And so we just kept moving the ball along and got to the point where we had Series A, which was, here, this is Gen 4. Nice $4 million round in 2009. Built that system, showed that it could process 10 tons a day. Then Kleiner Perkins and Waste Management, Total rolled in and said, hey, build us a bigger one. So we did. We built Gen 5 of this system. We deployed it in 3 locations in the United States, which I'm still proud of in a sense. I don't have a lot of pride per se, but proud that we were actually the first ones to take a commercial pyrolysis system with oil being pretty high. We made crude oil, by the way, right? So we're making a substance that we're selling to the refineries. That's our model. The one there is in Georgia. This one's in Waste Management's backyard in Portland, and this one's in Minnesota. They're all configured differently. They all could be. You're talking about 16 crock pots, industrial size, with cartridges that fit in them. That's how we designed the systems, to be modular, right? A little bigger than Brian's, but conceptually exactly the same thing. Couldn't put these on a truck, though. So we did that, and it worked. And we deployed it 3 times. And then oil crashed. $100 a barrel, $30 a barrel. Stayed there for roughly 2 years. We needed $65 a barrel to make things work. So they wound down one at a time. I think in Minnesota there, they repurposed this stuff to actually do UMO, used motor oil. So they did that. These assets were all scrapped, unfortunately. Actually, I bought all of these from Waste Management. So that was a fun auction because nobody knew what they were bidding on except for me and one other person. So let's grade it, okay? Plastifuel, decent CapEx. About $500,000 for every ton per day, maybe $600,000 per ton per day. OpEx, not as good. Had to have an overhead crane, do all the things, back and forth. You're moving 6,000-pound, 1,000-degree hot cartridges in and out of a system. Nobody liked that, including us, but that's what we did. Feedstock acquisition strategies, we were terrible at it because we had a person providing us with an enormous amount of great feedstock. He was our feedstock fairy. We had no idea how to go get feedstock, but he just provides it, so why would I have to learn that? The lesson was not one of our clients knew how to go get feedstock. Our team did a better job of go getting olefin-rich, source-separated plastic. Waste Management didn't do as good a job. Georgia didn't do as good a job. Minnesota didn't do as good a job. They just didn't know how to go about it. So acquisition of feedstock, terrible. Prep was easy. If it's plastic, run it through. Grinder, shredder, doesn't matter. The spec was okay. We did a pretty good job of saying, here's what we don't want. We don't want PVC. We don't want a lot of PET, but we'll take a little. So we knew what we were doing in terms of feedstock spec. And so we told our clients, here's what you need to do for feedstock spec, and they worked. The technology efficacy was very, I thought, I'm proud of this. I gave it a B grade, not an A. Every gallon of the several million gallons of oil those three systems produced got sold into commerce. In Oregon, we sold it to U.S. Oil and Refining, a boutique refinery in Tacoma, Washington. They bought every gallon at spot price minus 1%. So it was West Texas Intermediate, less 1%. That was a great contract. So very proud of the technology. It produced good product. Market conditions, $100 a barrel, B+. $30 a barrel, D. So it averaged out to be a C. All right, everybody follow that reasoning so far? You may not agree with it, but hey, I'm the grader. So, all right, so Agilix Gen 6. I left Agilix in 2014. We had Gen 6. This was the original pilot. My chief engineer and I sort of erected and started to work on. We did that for about a year and a half. I left the company. He actually left shortly after I did. And the throughput was never quite there. This is a twin screw thermoflight reactors. Clever. First system I've ever seen that actually self-cleans. You didn't have a char problem on the actual heat transfer surfaces. Amazingly simple, sort of like wickedly smart in how they self-clean their screws. The upshot of the downstream effect of that was, though, the screws cleaned themselves so well that they ground the char to an ultrafine powder, which then floated with the oil downstream and clogged up in other places. But hey, the screws were clean. And that's, so continual pyrolysis, twin screws, it works. You just create additional challenges downstream. They pivoted after I left to polystyrene or styrofoam back to styrene, which is the number 3 chemical in the world. So they understood the need to pivot when this machine wouldn't get the throughput and the market for oil was still down, right? Which those two conditions are going to force you to pivot, and they did a good job. The middle picture is, I think, the Toyo plant, only partially built. Ron would probably know more. And then, of course, somebody alluded to, I think Brian alluded to, Joe Valancourt, as the head of Agilix, realized feedstock is like, technologies are like the microwave oven. You got to feed it some food before a microwave does you any good. So you'd better understand how to feed a machine, not just have a cool machine. And so they spun off Cyclics as a daughter company, and just a smart idea. We'll see on execution. It's still to sort of be turned on and running, but we'll see. So let's grade. Wasn't there for all of the Agilix time after I left, but I'm still going to grade them. This is the Gen 6, not the Cyclics effort. Gen 6. CapEx per ton per day, terrible. The screws didn't give you throughput. I calculated it was like 2.8 million for every ton per day, like 2.5 times worse than Brightmark, for comparison. OpEx, great. Twin screws, they just clean themselves. You don't have to have a whole lot of people. Feedstock strategy, great. The prep was not great when they went from styrofoam to a compressed styrofoam ingot. That itself, there's a market for compressed polystyrene ingots. They could have stopped and sold the ingots, but they had to put them through a machine and then turn them back into styrene. So bit of a miss there on the prep. A lot of steps they had to do to get the machine right. But the spec was quite good. They knew what they were doing. Technology efficacy, great. Market conditions actually getting better, right? So oil's coming out. Styrene's a great market anyway. It's number 3 chemical. All good to go. All right, so we have PDO left. So don't chuckle, even though I do. So this is our sort of Gen 1. That's an original waste management system there, the original waste management vacuum skid there. We cobbled together a condenser in the background, put a little catalytic device there, and it worked. And we were able to make actually a fuel product, not an oil product, because oil's low, but fuel's always high. We've all seen that at the gas station. We ran Gen 2 of this system here. Same reactor, different condenser in the foreground, vacuum in the background, and then some of this here. This is sort of a catalyst full-scale prototype, which works fine. So we've advanced to the point where we can make our own fuel products if we want. And then along comes Shell Oil a couple years back at the Ag Plastics Recycling Conference, which is in a few days. And I said, what is Shell Oil doing at an Ag Plastics recycling conference? Oh, we're here to try to figure out how to get to 800,000 tons of mulch film that gets thrown away in this country every year. And I just looked at them and said, why? Oh, we want somebody to, convert it back into oil that we will buy and then turn that back into plastic. And I'm sitting there with Alan Youngsma, my partner, who's run Agriplast, the actual plastic ferry guy, for 35 years. And I said, well, Shell, he can collect it and I can turn it into oil, so you should just hire us. They don't invest in companies anymore, so they didn't. But we did produce oil for them, and they bought it, and we have a contract with them. So that's all good. We are currently working on our latest design, which is, I'm going to put this in here. This is not a PDO design right here. I'll get out of everybody's way so they can see it. That's an old competitor, publicly traded guy, John Bordnick. This was way back in 2008 or 9, but it's a rotary drum reactor, which is actually a pretty good design. Several people use it. Altera uses a rotary drum reactor. Others do as well. And it works, and it can be made pretty simple, and you can load it up with a lot of plastic, and it still works. So that's good. We're going to go with that. We've got our designs. We've been working on those for a year and a half. So let's grade me. How good of a grader am I on myself? CapEx per ton per day on the newest system will be about $400,000 to $500,000 per ton per day of processing. That's pretty good. OpEx is going to be pretty good because rotary drums don't need a lot of labor, and they're energy efficient. Probably not as good as Brian, but they're still energy efficient. Our feedstock strategy, we understand, so having done this now for 20 years, we understand the acquisition part. We understand the preparation part. We understand what the specs mean. So we've done this for a while, and we will continue to feed our own machine with our knowledge. So I'm grading myself out at an A there. Yes, a question from the audience, Dr. Dre. Hey, hang on, I'm just going to repeat the question, unless you guys want to intercept. All right, here you go.
Okay. On the two different reactors that you have there, what's the difference on the flash point since you're creating a fuel product?
So it's funny, the flash point, you can make the neat oil, and because the gasoline component is in the neat oil, the flash point's ambient. You can then separate the gasoline away, and of course the gasoline's flash point is ambient. The diesel cut and the wax cut, if we make those cuts, and we can, are, diesel cut is not quite diesel. It's not quite 140 degrees, it's probably 110, and the wax cut is something like 160 or 90 or something like that. Okay. The trick is you got to drive all that gasoline out of the heavier fractions, because if there's just a little bit in there, it just ruins the whole batch. Turns the flash point.
The retention time on the reactor is about the same for the two different reactors?
Yeah. Okay. Yep.
That was it.
She's analyzing stuff already. I'm worried. So technology efficacy, we've actually, using that old equipment, which was a single batch, run again and again and again and again and again, we made an entire isotainer of oil, sold it to Shell Oil, paid a fair price for it, and got us a contract, which is great. The new rotary drum will be, we think, more efficient. It's 10 times the load size of the old sort of crock pot, as I like to call it. And, but the market conditions now, and Brian knows this, everybody knows this, that's in pyrolysis, the market conditions now, there's never been better. You've got all the oil companies each wanting their own 1,000,000 tons of oil by 2030, which is ridiculous, but they all do. And there's 30 of them, and if you add up all that plastic, there's not enough waste plastic in the entire world to feed all their demand. So I think that's it. Oh, parting thoughts, then I'm out, Gene. I think we still have some time, don't we, Brian? All right. Parting thoughts. Understand your business value prop. Don't just fixate on your technology. Everybody does this sort of originally and initially, and then Brian probably didn't because he's smarter than that, but we just fixated on the shiny object, and you just can't do that. You have to look at the whole picture. So understand that, not just the conversion part. If you can, avoid the problem of, I need plastic, please feed me. Because now I have the problem, you're the solution to my plastic need, so you're going to sell me plastic. If you can, which is what Brian and I think, and others, you need to address the problem if somebody says, can you handle my waste plastic? Well, of course we can, yeah. And we won't even charge you much, less than a landfill. How's that? Good? Perfect, okay. So you want to be the problem solver, not the entity having a problem with waste plastic. Your feedstock spec, make sure you understand, it's not just a technical spec around what heteroatoms are in it or what it's composed of or comprised of. There's a spec for acquisition, and there's a spec for preparation, right? Preparation is more that people understand. Does it have to be a pellet? Can it be a flake? Can it be an agglomerate? What can it be? Make that as versatile as you can if you're in this space, because you need the versatility. Relationships are more important than transactions. If you're going to have customers, whether you're solving their problem, whatever, engage with them personally. Don't just like assume you're going to make the milk run and pick up their plastic every single week. Someone's going to come in there, warm up to them, and take that business from you. You got to be on this. This is what we learned with 20 years of agricultural waste plastic collection with farmers. Go out and visit the farmers, not in your Mercedes. Okay, it just doesn't work that way. Meet your client on their level and where they live. Lastly, I think Ted's going to be here in a couple days, right? Okay. Ted with Doc 7 a couple years ago came up to the microphone. It's all about logistics. He could have dropped the mic right then and it would have been a great talk because it's all about logistics. You have to think outside the box. EFD actually did that way back in the day. Why? Because they had a trucker already in the logistics game thinking outside his box about how to get plastic. I think that's it. Time for the naysayers and the skeptics.
Hang on, before you go too far, before Brian grabs the mic.
Yes.
All right, so I kind of got a multi-part question here, and kind of curious with all of the different ventures that you've been through, from a feedstock aspect of things, how has, when a lot of this started, and we started trying to do this with films, and you're talking back in the early 2000s, whenever some of these ventures that you've been on trying to make this happen, that was when films, people would just give it to you. I mean, it had no value to it, but you were able to convert it, and then, thanks to your technology, it became valuable. And so obviously that has increased, the monetary value of what that feedstock needs to be. So my question is, how have you seen that, I guess my first question, how have you seen that kind of evolve your technology and what your offtake agreements need to be? And then my next question is actually through the offtake agreements and how that works with feedstock, but I'll let you answer that one first.
So what we found, at least with ag plastics, which are interesting because they're almost always just olefins and not much else. You don't see a lot of PVC. I know everybody thinks about irrigation piping, but that's usually residential piping. It's not really industrial. I own a farm. It's not a very big farm, but I own a farm, and I sort of understand the farming shtick, if you will. And I have a lot of respect for farmers because they do stuff I could never do. It's already sort of self-sorted, but it is dirty. There can be dirt, of course, and other things. There can be pig manure on it if it's a certain kind of thing. There can be all sorts of things on the plastic. So if they've got a big batch of dirty film and they just want to get rid of it because it's taking up a lot of space, you wait for that call and you say, I will be right there. I'm going to pick on Andrea because, I know her. Andrea calls and says, hey, Kevin, I got a truckload of film. Like, be there tomorrow, or I'll put you on my schedule, be there whenever. And I will show up that day, and I will pick it up, and I will probably kibitz and gib-gab with her for a little bit, and then be on my way. And I will keep that relationship going and solve her problem every time she calls. That gets you enormous goodwill, and it also cements that I'm a problem solver. If you were to Google Alan Youngsma, who's the owner of Agriplasty, and his wife Dari, you would not find them in Google. They probably don't even exist there. But people will tell you almost with religious fervor how much these two people solve their problem every single day of the week. Because they've been doing it for 35 years. And they were farmers. And so they solve farmers' problems. So it's connecting with, your client in a way that I'm going to solve your problem no matter who you are, no matter where you are, I'm going to solve your problem. That tends to, they're just happy to solve their problem, whether it costs them a tiny little bit of money or you came and got it for free or whatever. They're just happy your problem solved because plastic does one thing about plastic. It takes an enormous amount of volume for the weight. And so you're solving a problem typically because it's loose on their back 40 and it's piled up now 16 meters high, and they can't even see the sun because there's, it's blocked out by the plastic. So it's just solving a problem. We don't do feedstock agreements. People have been talking about feedstock agreements. You need that, otherwise you're at risk. We get the feedstock. We are the feedstock agreement. We are the contract with every single one of those people. So that's how we solve that. Offtake agreements are offtake, right? You just got to prove to an oil company that you can deliver. But in terms of feedstock agreement, we own that first step. Box 1, I like to call it. Box 2 is pyrolysis. Box 1 is acquisition and prep.
Yeah.
And if you own it, you don't have to have a contract.
And
Yeah, I was going to add a little more to that. In California, there are no pyrolysis players except for us. So I think in California, where the landfill, the tipping fees are like $100 to $200. I mean, the total cost to take to landfill. They're going to pay us for a very long time. And nobody else dares come to California. Nobody dares go through that town hall meeting I did last night. It's going to be a while. Now, I welcome others. I want other players. We want to support each other. We need a full effort in California to get pyrolysis chemical recycling here. But for this market, it's going to be it'll be a while. And it is, I think on my slide, I called it community-based procurement. And it's basically exactly what you're saying. It's the farmer thing or your community. You're solving a problem. In the Bay Area, we're actually having people truck very far to us, all across the Bay, like an hour-and-a-half trip, and pay us to take their films, their baled films. So I don't think that'll be forever, but it might be for 10 or 15 years.
Yeah, I think I guess kind of the second part of my question, or I guess now is probably becoming more of a statement than anything, is, I've tried to divide this into 3 scenarios. So you have your offtake agreement, which is ultimately kind of what your, what the rest of your system can be based on. So with your offtake agreement, that's typically a fixed price. Then you have your operating cost, and that's very minimal fluctuation in that. So then your feedstock cost is what's kind of the driver there, and what can change. And taking this outside of California, that's something I think has been one of the big failures with some of these larger companies that are trying to come in here and take a bite out of this market, because there is, like you said, the Shells and the Dows, they're promising these huge contracts, and how big, how fast, and how much can you give us? And they take this bite off trying to do 8 to 12 tons an hour of material and realize, okay, we want to build a system that's capable of processing this at 8 to 10 tons an hour. Well, then they realize how difficult it is to find that much material of exactly what that system was made of. And it causes failures. And I think that's, kudos to you, Brian, and you as well, Mr. DeWhitt, to go after this in a smaller quantity, because I think the success rate of that is a lot better. And having 10 of these in different regions is a lot better than having one that doesn't succeed. And right now, the biggest thing that we need in this industry is for these to succeed.
Yep.
Because that gives us a better opportunity to try to conquer the plastics problem without trying to take a big bite of it at one time. And I think that was what the expectation was initially. That we have, there's all this plastic out there, and we have to fix it right now, and we can divert this much. And it saw its failures, and it really kind of it set the industry back a little bit, because investors got very, they were very reluctant to put money out there in a capital atmosphere, capital investment atmosphere, to try to put money into those systems. So. Kudos to you guys for kind of taking that that descaled scenario and making it work. I think that's a great approach to it. So, thank you guys.
Brian, I saw your slide there on the community sort of effort, and I thought, dang, he's got it now. I was sort of hoping that you were a year behind me in that, but
Secret.
no, but I say that in jest. It really is true. You've got to attack this problem and service the local community. And that community can be rather, in our case, it's farmers. They're spread out all over the place in rural America. But in general, serving the community is just key, and Brian's done a really good job of articulating that as well.
So John, I think maybe part of your question was how do the off-takers, the whole value chain, do the off-takers, are they willing to pay more if we have to pay more? Nope, that wasn't it. Okay. Well, that's a whole separate issue. So, yeah. Mm-hmm.
That's the struggle there, is that, you know, when your offtake agreement is set for 5 years, 3 years, I mean, material can change and material needs can change very quickly. You know, just the same way that, you know, you've basically given value to films. I mean, you're one of the pioneers of that now. So, you know, that's something that's really hard to navigate and try to find that, you know, this is what our offtake cost is. So if that feedstock fluctuates, there's not really a whole lot of room in there. And, you know, in us as an equipment vendor, you know, we try to make sure that we give you as broad a scale as possible to make that work. But that's really one of the only, in the feedstock side of things, that's one of the only scenarios that you can really have that fluctuation.
Kevin, are you hearing what I'm hearing? That maybe the vendors are willing to fluctuate?
I certainly heard they'll cut their margins in half, Brian, that's what you heard.
We have to build you a more expensive system to be able to make it fluctuate. How's that sound?
So there was discussions, and I won't say which companies or whatever, there were some negotiations out there that the off-takers would pay more if you had to pay more for your feedstock, just to get the industry started. So there's less talk of that, but that was a discussion. Yeah, so one of the things I did want to talk about is, like, Cyclics does a really high quality offering, you know, preparing that feedstock and prepping that, but that can be pretty expensive, and others are like them, and so there's a full gamut of quality that's provided out there. So question to the speakers is where do you see things going? You see potential consolidation and you know, vertical, horizontal, both, with respect to feedstock and the technology, and all the way, maybe even all the way to the upgrading of the oil.
What do you think, Leonard? Turn your microphone on.
I think it's similar to what you guys are talking about with decentralization, kind of what we've been doing at eFactory 3 with all the mobile machinery that we work with. I think that's kind of the same direction that we're going. You know, we found that when we can bring machines to a landfill or to a MRF or to wherever the client actually is, eliminate those transportation costs and do these processes on site, you know, the same thing, rather than trying to build, because I can't tell you, been working in the industry for 10 years now, I can't tell you how many projects I've worked on where we've got people saying, I want to do 30 tons an hour of film, right? And I want to do it in BFE, Alabama, right? So how are you going to get all that plastic film to that location, Alabama, right? How are you going to get that much material there? You're not. Yeah. And I guess they're thinking economies of scale, right? I do that much per hour, then it's going to make it worth it. Well, if you can't even get the material, then it doesn't really matter. Yeah. But if you can get that piece of machinery to where the feedstock is, then it starts to make a little bit more sense. So I think it's kind of going a similar direction.
So consolidation, interesting. So the industry's pretty young still. There's not been a lot of traction. I think, Brian, we've got as good a shot as any of getting small amounts of traction and having people sort of look at that and say, oh, that'll multiply well. I've had some really pretty smart people in the oil side of things, and I would really love, I'll talk offline about this with Michael Long, but I'd really like to hear his opinions on this as well. They have said, we think there's room for one, maybe two of the sort of big project players, right? The 100 to 200 to 300 ton per day players. Now, ExxonMobil's got their Extend technology right now, which is big. I think LyondellBasell's trying something in Europe, which they're hoping to port over here. We don't know. I don't know if that'll happen. But this person told me there's room for big, medium, and small, because it takes all three of those likely to attack what is an enormously distributed problem. And there's little pockets of lots of plastic and little pockets where there's very little. And so I told this person, I said, listen, I believe the small-scale players are going to be on the podium, Olympics, Tour de France, whatever pick your metaphor, we're going to be on the podium. We may not be the yellow jersey or the gold medal, but we will be on the podium with maybe a big player and maybe a few medium players. But there's room for everybody to sort of see how the ecosystem sorts itself out. I really believe that if we get traction, which I think we can do quicker, guys like Resynergy and PDO and Greenback, if we can go quickly enough to get some traction in 3 or 4 projects, people are going to look at that very, very carefully and say, their CapEx is low, their risk, sort of capital risk is low. To Andrea's earlier points about financing, listen, a $300 million project, I can do 30 $10 million projects for that same amount of capital. And if one of them goes offline for some earthquake-ish type of force majeure reason, I've got 29 out of 30 assets still working. That's very de-risked because it's very decentralized, right? So there's things like that that I think will work.
Yeah, so this is a question for Andrea.
Turning the tables.
Just so you know, he was talking about financing 30 sites of 10 million rather than one site that's the same value. Do you see financiers willing to do multiple sites or?
Yeah, they're absolutely definitely more willing to do multiple sites. Most of the large financiers won't do anything under 50 million. So really, they want to see a project around 150 million.
Mm-hmm.
So you won't get them to work for you with the lower amounts, but if you have some pre-development on the other sites and you have a roadmap and a trajectory, that's a really good way to go.
And to be fair, Andrea, and a working model, we've got 1 or 2 sites already working, already have P&Ls, they're already in the black, and we can show them those models, right, and say, we want to build 15 more just like this. We need 150 million. It's going to go a long ways, is it not?
It is, but you also have to have some thought about where they're going.
Hmm?
So you can't just say, hey, I'm going to do 5 additional sites. You say, well, we've done some pre-development in these additional sites. Here's some of our site selection work we've done. Here's some of the optics of it. And that's how you get like a 1+5 or a 1+10, depending on how much work you've done.
We've got 200 sites in the United States, everywhere except California. We're leaving that to Brian.
You know,
We'll have 200. We'll have
California's
200
tricky.
sites here. Yeah. So, Gene, am I allowed to ask more questions of the audience?
Yeah.
Very new format here.
So this is more kind of an opinion poll, okay? So what is your opinion or feeling on processing your own material versus buying pre-processed material?
That's all we do. We go get our own material. So we are the acquirer, and aggregator, and preparer ourselves.
Why do you choose to do that?
It drives down the cost of goods sold enormously if you know what you're doing.
Yeah.
If you don't know what you're doing, you can stub your toe for several years and maybe create a few pyrolytic fires like I have done.
Yeah.
But I'm hopefully past that.
I have my opinion on this already, so yeah.
So-
I didn't want to dilute the answers with it.
So one really interesting thing happening in the industry right now is there's the first major failures. Like there's a number of major pyrolysis companies that have gone bankrupt recently. What that's done is there's a lot more sharing. Like Kevin wouldn't have shared this in the days of Agilex, like what the problems are, or clogging and so forth, and sharing all that. But there's also people moving from, say, Brightmark. We hired recently people from Brightmark, very, very skilled people, fairly high level, also from Fulcrum. And they had some serious clogging at Fulcrum, and there's some really interesting stories. But a lot of that experience is, I sort of dreamed one day we would have multiple companies come together and people would share their thoughts, and it's just happening in a different way. So people from Cyclix, there's been a major change there that's not necessarily public yet, but there's some serious players there that have been super helpful to a lot of people in the industry. So it's helped us. Our timing is really good. We didn't hit any bad market. We're in a good spot now. You know, count our blessings, but it's a really good time for collaboration and accelerating this in a collaborative way.
Yeah.
I have a thought on your question. I mean, to me, it doesn't really matter whether you do it in-house or, buy it in, because you're going to buy the machines from me anyways. Doesn't matter who buys them. But that's just to say
He's
that,
not wrong.
I think we've realized, as I was talking about during my presentation, that creating feedstock is not that easy, right? It's not a one-size-fits-all thing. And while I think, using it to drive down your costs of goods is wonderful, and the people that can do that, I think that's great. But we, even as E-Factor 3, have seen more and more people crop up, especially in the last 4 years, that are just creating feedstock. They have no interest in doing the pyrolysis. And I don't think that's a bad thing. I think that lets people specialize on things like, all right, we're in this area of the country. We know our waste very well. We know we can create this spec very reliably. And then we have Brian's company and Mike's company and John's company that can all use that feedstock, right? They don't all have to individually build their own feedstock preparation.
Right.
I think it's necessarily actually a good thing to have that diversity.
Yeah, I mean, and honestly, once it's processed like that, transporting it is a lot, you're not transporting waste now. I mean, you're transporting something that has a lot more value and a lot better bulk density. You know, my struggle with it, and having been on the advanced recycling side of things and then come back to the equipment manufacturing side of things, you know, my struggle with it was always, you know, you kind of lose touch with that, with the quality control of, you know, what that material is. You can't walk down your line and say, ooh, I don't know, like this material doesn't look as good as what, you know, what we would expect, and maybe let's divert that for a little bit and then, you know, try a different batch. Or, you know, your in-feed operator is basically your scientist there, that they can kind of pick and choose what goes into it. They can, you know, kind of dummy down some of the nice material and add some lower quality material in there to make a recipe a little bit better. So, you know, for me, I always kind of struggled with that, you know, yeah, you know, I love the fact that there are other people out there creating this material for a lot of other, you know, not just one processor, for instance. But, you know, I think that's great. But, you know, for me, when I was in the advanced recycling side of things, like, man, you really kind of lose grip on that quality control.
Yeah,
But
so
not everybody can do has the CapEx to be able to make that happen.
There's a question over there, but John, yeah, everybody I think knows what a honeymoon shipment is. This is her shipments. First few shipments are awesome, and then wait, where did it go? Yeah, so where did the mic go? Yeah, so yeah, you can have a lot more control.
Shell Oil's people, and they're just wicked smart, like a lot of people are. We debated, they think that decentralized feedstock prep, followed by moving that material to centralized locations, is just as good a strategy, if not better, than the decentralized technology approach. We respectfully disagree with them, and not you know, militantly or you know, with a lot of fervor. Just like we just don't think so, because we've been doing this part of it so long. We think you guys are get out of the office, have your PhDs get out of the office, out of their Skunk Works lab, and actually come do some stuff, and we'll see. But it's a viable approach, right? Decentralize the feedstock acquisition and preparation. Sure. No, we just teed up Andrea again. Oh no.
No, it's a good thing. So, you know, some of the things to put into your thought process on your process train is if you take out that front end MRF and you're not having those employees, you miss out incentives because you won't meet the requirements for enough employees. So most incentive programs are 50 full-time employees or more.
Aha, there's a head shaking over there. Another question? Or one more?
Hang on.
Oh, I tickled Michael with a little bit of song.
First off, just a comment on upstream, downstream. The way I view it, you're losing a knob. Sure, you could have distributed upstream feedstock prep, but now you, the processor, no longer has this knob to turn to adjust your process. My actual question to both of you, has there been analysis, or am I wrong in assuming that there's some gases being generated in either of these processes? I would be very interested in having a chat with you about what the composition of these gases are and looking at if these processes are scaling, which I know you're small, modular, but really looking at whether there's some potential for value add to those gases. I'm assuming they're just being flared if there are any right now.
Yeah, so we've been looking at this a lot. So there's three things you can do with that. There's gases that they range from 15 to 25%, depending on whose process or whatever. But they're gases like methane, ethane, propane, just light gases. And you can either bottle those, or you compress them and sell them as gases. You can flare them. And in California, you have to have a super, super destructive 99.99% flare. It's an oxidizer. And then the third thing, you can co-generate. And it turns out if you use a super efficient, modern, very expensive mainspring generator, which is it's a reciprocal generator, there's no flame. So there's not actual combustion. It's just high pressure reciprocal piston coming together. It's the pressure and the lower temperature that gives it the energy, but that because it's not a high enough temperature or doing a burn, it's very, very clean. And then they have a catalytic, they have a catalytic converter, whatever, on the output, so it makes it even cleaner. So almost no dioxins like you would have in a regular generator. So yeah, co-generation, third way. Yeah.
So do you have experience with that, or is that all modeled data? I mean, I think it's great. I love the mainspring technology, but I'm curious how that's going to play out. I haven't found someone who's actually using one yet. And
Yeah, I
really
think
looked
they
at the
just have
result.
one. They're very successful with one or two customers that are taking a lot of their capacity. And yeah, we're occasionally in discussion. Our first site will just use a very, very efficient oxidizer, but our plans are to use that or something very similar. Yeah.
I'm an analytical chemist. I've got reams of data on those gases, so no problem. They're there. It's, for us, we characterize it as a sort of an off-spec propane, and we can blend that with our with normal propane and run our burners on that. So, yep.
So any other questions?
Do we have any more for the audience, Brian? Leonard, any questions for the audience? Saw John Angan come in late. John used to work at Agilix. He was one of the feedstock experts that I spoke about a little bit earlier, who knew sort of better than any of our clients how to go get source-separated plastic. So, welcome, John. No worries.
Let's do this, if you all don't mind. Part of the value of these conferences is the networking. And I don't know if everybody's had a chance to meet everybody within the conference, but I'm going to do this. We've got 10 minutes. Mike, I'm going to start with you.
You're welcome, Gene, for that extra time that we allowed you.
Thank you. I want to have everybody at least go around the room, introduce yourself, who you're with. We've got 10 minutes, so no long-winded discussions about yourself, all right? Mike?
I'm Mike Hart. I'm the CEO of Sierra Railroad Company and major investor in Sierra Energy. Scott's here from Sierra Energy. I was born in New York a long time ago.
Hello, I'm Scott Vander. I'm a partner at Energy Transaction Advisors, a boutique consultancy. We do a lot in the waste energy space, and we actually do a lot in other spaces as well. So take a look at our website or come by the booth if you want to know more.
What's your favorite color?
Yeah, Timothy Kelly, Imperial Valley Economic Development Corporation. I also sit on Team California, our statewide marketing organization in CalEd. If you want to do a project in California, let me know. We'll connect you with the governor's office. We'll connect you with every region throughout the state. Thank you.
Good afternoon. My name is Reginald Ofuani. I'm the Community Beautification and Waste Management General Manager. I'm a member of Sunshine Swana chapter and very active in most of the things we are discussing today. Thank you.
Hi, I'm Dr. Andrea Neal. I'm the president of Blue Capital, and if you can't guess, my favorite color is blue. I have a technical background, but I'm the finance gal.
As previously stated, I'm Jim Henderson, Vice President of Business Development for Heartland. I know I talked an awful lot about the heliostorm and the dryer, but also think about us for our concentrator technology for leachate management and other very difficult to treat aqueous streams. Thanks for your time again.
I'm Kellen Donahue. I'm based out of Denver. I work for Jim, and the concentrator is what I've been focusing on.
Nice.
Michael Long from Chemical. I rambled a bunch earlier. Technical guy, disillusioned with academia, applied, now trying to help bring this industry to, all these industries around here, to success, as I've come to different conclusions than a lot of the modelers and the academics on what's really needed. That's all I'll say there.
Travis Miles with Viably. I'm the sales manager for California. We offer stationary and mobile design for waste and recycling projects.
Hi everybody, I'm Pascal Neubecker. I'm with Manuscal USA Corporation, also like John in the material processing sector. Also very deep into feedstock preparation, just as Mike.
Hello, I'm Hartmut Lennartstad. I'm the owner and founder of eFactor3 and still hold the position of the president. And, you know, the rest of it you just learned through the presentation.
Hello, everybody. I'm Mike Kersey. I'm the president of Mondescall North America. Mondescall, we work with a number of different groups, eFactor3, Veco Plan, and others, to densify and grind process material in order to meet the needs of pyrolysis.
My name is Jim Andrioli. I'm with Baker. I was with Baker Commodities Incorporated. I am now retired.
Hey everyone, Jimmy Andrioli II. I am currently with Baker Commodities, and we're kind of in the current waste to energy sector.
John Toddy with Veco Plan, sales manager for North America in the waste, energy, and medical waste sectors.
I'm Andrew Earls. I'm a research engineer at Southwest Research Institute. We are a nonprofit contract research business, and we regularly work in gasification and pyrolysis.
Yeah, hi, I'm Scott Kranek. I'm the CEO of Sierra Energy, the company that Mike talked about earlier. So we have a Feedstock technology that transforms really any type of waste, really profitable projects into renewable fuels and chemicals.
Hi, I'm A.B. Gutman. I'm a research engineer out of Southwest Research Institute. I help with fuels and lubricants and new tech.
Hello, I'm Jacqueline Barnum. I am been working with Native Nations for about 20 years, currently running a liquid remediation facility on tribal land.
Good afternoon, everyone. James Swart, Director of Special Projects with the Solid Waste Association of North America, SWANA. I will save sharing more about SWANA because you're going to hear it in just about a half an hour.
Hi, my name's Nick Kaur. I'm the Director of Engineering with the Lancaster County Solid Waste Management Authority. Kind of like James, you'll hear a little bit more from me in a half hour or so.
Hi, I'm Rebecca Tabor, and I work with Tax and Ledger. We do tax solving for smaller clients, and we are working on tax credits, so I'm here to learn.
Hi, I'm Jesse Rubin with Reformed Energy. We're a gasification company coming online probably in the beginning of 2026 with our first commercial project out of Virginia. Very similar to Mike's Fast Ox technology, but startup new coming online just in the next few months, so stay tuned.
Hello, Justin Davis, Director of Business Development for AMP. We design, build, and operate advanced sortation technology that can be used in MSW, secondary sorting, plastic, or feedstock preparation.
Hello, everybody. I'm John Engen from Tetra Tech, Solid Waste Division. I'll save the infomercial on Tetra Tech for later, but I'm an industry veteran, both as an operator and as a consultant for going on 40 years now, so a long time.
Hello, everyone. Christine Arbogast, and I am also with Tetra Tech. I head up our Western U.S. solid waste practice, and we have about 600 solid waste specialists nationwide, and are often asked by our clients what's going on with conversion technologies. So I love coming to this conference.
Hi, everyone. My name is Kauser Viziftar. I'm a civil engineer with Los Angeles County Public Works, as you heard, and I'll also be on the next panel, and we'll share more. But yeah, we work on solid waste collection, processing, disposal, alternatives to technologies, solid waste programs, pretty much anything to do with solid waste.
Awesome. Did that make sense?
Yes, perfect timing, yeah.
All right, any other questions for the panelists? All right, why don't we go to break and have a cup of coffee? We'll be back here in a half an hour to wrap it up at the last session on Swan is going to run for us. James is going to run. We're going to be talking about waste energy and I think some other things on waste conversion, okay? See you all in a half an hour.
I don't know.